There is a house on the edge of Lancaster County that was built in 1803. The family living in it today is the fifth generation to sleep under that roof. The original clay tiles are still on the roof. The limestone walls are still plumb. The hand-hewn oak beams in the cellar have not moved a quarter inch in 200 years. I have driven past that house my entire life. And I want to tell you something that took me most of my 80 years to fully understand. That house is not still standing because of luck. It is not still standing because the Amish pray harder or work harder than anyone else, though they do work hard. It is still standing because of 5 specific material choices. Choices that modern builders quietly stopped making sometime around the middle of the last century. Choices that were replaced not because they failed, but because they were slower to install and harder to source. The house your grandfather built may already be showing what happens when you make different choices. The house being framed down the road from you right now almost certainly will not see 200 years. Stay with me, because what I have watched across 8 decades of living next to the Old Order is worth your time. I was born in 1943 in a farmhouse 3 miles from an Old Order settlement in central Pennsylvania. My father knew those families. His father knew their fathers. So I have had a long time to watch. And what I watched, starting around 1950 and accelerating through the 1960s, was a quiet abandonment. Not a dramatic moment, no announcement, just a slow drift away from materials that had served builders for 2 centuries, toward materials that were faster, cheaper at the point of purchase, and easier to ship on a flatbed truck. Lime mortar gave way to Portland cement mortar. Limestone block gave way to concrete block and then to wood-framed walls with vinyl cladding. Hand-hewn timber gave way to dimensional lumber, then to engineered wood products. Clay tile roofing gave way to asphalt shingles. Wrought iron hardware gave way to stamped steel and then to zinc alloy castings. Every one of those substitutions made a house faster to build. Every one of them shortened the useful life of that house. I am not saying this to be romantic about the past. I have watched enough Amish barns burn and enough Amish cisterns fail to know that old does not automatically mean better. But I have also watched enough modern houses develop rot behind their vinyl siding, enough Portland cement mortar crack and spall off limestone foundations, enough asphalt roofs fail at year 17 to know that something real was lost in that trade. The Old Order kept building the old way. Not out of stubbornness, though outsiders often called it that. They kept building the old way because they watched what they built. They lived in what they built, and they expected their children and grandchildren to live in it too. That changes what you choose to put in a wall. If you have ever wondered why the houses in an Amish settlement look different from the houses around them, older looking, heavier, more settled into the land, this is the answer. It starts with the materials. Drop a comment below if you have ever lived in or visited a house that felt genuinely old and genuinely solid. I want to know what that felt like to you. The first material is limestone. And to understand why it matters, you have to understand something that most modern builders have never been taught. Walls breathe. A wall in a living house absorbs moisture and releases it. It absorbs heat and releases it. It expands slightly in summer and contracts in winter. A wall that cannot do those things gracefully will eventually crack, rot, or delaminate. The question is not whether moisture enters a wall. It always does. The question is what happens to it when it gets there. Limestone handles moisture the way a good wool coat handles rain. It absorbs what it must, holds it distributed through its mass, and releases it slowly as conditions change. A limestone wall 2 feet thick, and the Old Order built them 2 feet thick, creates what builders used to call a thermal buffer. The interior of that wall stays close to the same temperature regardless of what is happening outside. I have stood in the cellars of houses built this way in the middle of August. The temperature down there, without any mechanical cooling, holds at almost exactly 55 degrees Fahrenheit. Not because someone engineered it, because 2 feet of limestone set into the ground and capped with a timber floor simply does not allow the heat to move quickly enough to matter. The Old Order families I watched growing up stored their root vegetables, their canned goods, their dairy in those cellars. The limestone was not decoration. It was function. Modern concrete block can be made to look similar, but concrete block is porous in a different way. It wicks moisture toward its interior rather than distributing it, and it has almost no thermal mass compared to solid limestone. The difference is not small. It is the difference between a wall that manages its environment and a wall that merely separates two sides of it. The Amish quarried local limestone when they could. Lancaster County, Holmes County in Ohio, the limestone belt running through Indiana. The Old Order settlements are not randomly placed. They are placed where the stone is. That is not coincidence. The second material is hand-hewn timber. And the detail that most people miss is not the size of the beams. Though they are large, 12 by 12 white oak is common in the older structures I have walked through. The detail that matters is the surface. When a timber is hewn with a broad axe rather than sawn with a mill blade, the surface of the wood is compressed rather than cut. The axe pushes the wood fibers down and to the side. The saw severs them. That difference in surface condition affects how the timber weathers, how it accepts moisture, and how long it resists decay. A sawn surface is open. The fibers are cut across and moisture can enter the end grain easily. A hewn surface is closed. The compressed fibers resist moisture penetration the way a leather sole resists water better than a cut foam sole does. I have walked through Amish barns built in the 1840s, where the original hand-hewn timbers are still sound, not restored, not replaced, still carrying load. The bark side of the log, which hewers often left partially intact on the less visible faces, contains the densest wood, the part of the tree most resistant to insects and rot. Mill-sawn lumber removes that layer in the first cut. The joinery used with these timbers also matters. Mortise and tenon joints, secured with wooden pegs of a slightly different species than the beam itself, allow the frame to move as a unit. When the building settles, when it expands in summer and contracts in winter, a pegged mortise and tenon joint accommodates that movement. A modern metal connector plate does not move the same way, and over decades the stress concentrates at the fastener point. Be honest with yourself for a moment. When you look at a building and feel that it is permanent, that it has weight and intention, what you are often responding to is the timber frame inside it. The Old Order kept building with hand-hewn timber long after sawmills made it unnecessary, because the men doing the building had watched what happened to the structures that switched. The third material is lime mortar. And this one may be the most misunderstood of all five. When Portland cement mortar replaced lime mortar through the middle of the 20th century, it was presented as an upgrade, stronger, faster setting, more consistent, and on those measures, Portland cement mortar is stronger. The problem is that in masonry, the mortar is not supposed to be the strongest element in the wall. The stone is. Lime mortar is softer than limestone. That is intentional. When a masonry wall moves, and every wall moves through thermal expansion, through settling, through frost, something in that wall has to absorb the stress. In a lime mortar wall, the mortar absorbs it. The joint flexes slightly, redistributes, and holds. In a Portland cement mortar wall, the mortar is harder than the stone in many applications. When that wall moves, the stress has nowhere to go. So it goes into the stone, and the stone cracks. I have watched this happen. I have seen limestone farmhouses repointed with Portland cement in the 1960s and 1970s, well-meaning repairs, and watched the stone begin to spall and crack within 20 years. The original lime mortar joints on those same walls, untouched, are still intact. The Old Order masons. I watched as a young man mix their own lime mortar on site. Quicklime slaked in water, combined with local sand, sometimes with a small addition of animal hair for tensile strength, a practice that goes back to Roman construction. They let the mortar cure slowly, kept it damp in hot weather, and understood that lime mortar reaches its full strength over years, not days. That patience is part of the answer. A wall built with lime mortar and allowed to cure properly will continue to carbonate, to slowly reabsorb carbon dioxide from the air and harden for decades. Some of the lime mortar in the oldest Amish structures I have examined is harder today than it was at year 10. It is still working. If you know a stonemason, share this video with them. This is the conversation the trade stopped having 60 years ago, and it is worth having again. If what you have heard so far feels like something you have always half known, that something real was traded away in the name of convenience, then leave a like on this video. It helps this kind of content reach the people who need to hear it, and I want you to stay with me. Because the next two materials, the clay tile and the wrought iron, are the ones that most surprised me when I finally understood why the old order never stopped using them. What I am about to describe in the next section is the reason some of those roofs have not been touched in 120 years. The fourth material is clay tile roofing. And I want to give you a number before I explain it. The asphalt shingle roofs being installed on most American homes today carry a manufacturer's warranty of 25 to 30 years. In practice, in the climate conditions of the Northeast and Midwest, freeze-thaw cycles, summer heat, ice dams, experienced roofing contractors will tell you that 15 to 20 years is a more honest expectation before replacement. The clay tile roofs on the oldest Amish farmhouses in Lancaster County have been in place for over 100 years. Some of them on the structures built before 1900 have never been replaced. That is not a small difference in performance. That is a fundamentally different category of building material. Clay tile works the way it does because of what clay is. Fired at high temperature, clay tile becomes essentially inert. It does not absorb water the way asphalt does. It does not become brittle with UV exposure. It does not bond with ice in a way that tears it from the roof deck. The thermal mass of the tile moderates the temperature swings at the roof surface, which reduces the stress on the underlying structure. The interlocking profile of traditional S-curve or pan and cover tile creates a drainage channel that moves water off the roof without relying on a continuous waterproof membrane beneath. The tile itself is the water management system. It does not depend on felt paper or synthetic underlayment that will degrade in 15 years. The old order used locally fired clay tile when they could source it and imported European tile when they could not. I have seen German and Dutch tile on Pennsylvania farmhouses built by immigrant families in the early 1800s. Those tiles crossed an ocean and have since outlived every asphalt roof installed in the same county. The objection I always hear is weight. Clay tile is heavy, significantly heavier than asphalt shingles, and the roof structure must be designed to carry it. The old order understood this. The timber frames under those roofs were built to carry the weight of the tile, because the men building them knew what the roof would be made of before they raised the first beam. The material choices were integrated. They were not made one at a time. The fifth material is wrought iron. And this one requires a small lesson in metallurgy because the difference between wrought iron and what replaced it is not visible to the eye, but it determines how long the hardware lasts. Wrought iron is iron that has been worked, hammered, folded, worked again, while hot. That process distributes slag inclusions through the metal in long, thin threads running parallel to the surface. Those slag inclusions act as a barrier to corrosion. When wrought iron rusts, the rust forms a stable surface layer, a patina, that slows further corrosion rather than accelerating it. The metal rusts from the outside in slowly, and the core remains sound for generations. Cast iron, which replaced wrought iron for many hardware applications in the late 19th century, and stamped steel, which replaced both through the 20th century, corrode differently. Cast iron is brittle and pits. Stamped steel rusts through. The corrosion is not self-limiting. A stamped steel hinge in a damp barn environment may fail in 20 years. A wrought iron hinge in the same environment, made by a blacksmith in 1870, may still be functioning. I grew up near a blacksmith who made hardware for the old order families in our area. He was still making strap hinges, door latches, shutter dogs, and gate hardware by hand into the 1970s. His customers were not buying from him out of nostalgia. They were buying from him because they had watched what happened to the catalog hardware their neighbors used, and they preferred the iron. When he retired, the old order families in that settlement drove further to find another smith. Some of them began sourcing from blacksmiths in other communities. A few of the younger men in the settlement learned the trade themselves. That is not stubbornness. That is a community that has done the math across generations and knows what the numbers say. The wrought iron hardware on the oldest Amish structures I have examined is not decorative. Every hinge, every latch, every shutter hinge is still functional. The doors still hang true. The latches still catch. The hardware has outlived the men who made it by 100 years, and it will outlive the men examining it today. Here is the thing I most want you to understand, and it is the thing that gets missed when people talk about any one of these materials in isolation. The limestone wall, the hand-hewn timber frame, the lime mortar, the clay tile roof, and the wrought iron hardware are not 5 independent choices. They are one integrated system, and the reason that system works across 200 years is that every element of it was chosen with the same set of values. Durability over convenience, repairability over replacement, local sourcing over catalog ordering, and the expectation that the building would outlive the builder. Consider what happens when you substitute just one element. You replace the lime mortar with Portland cement. Now the wall can no longer flex. The limestone begins to crack at the mortar joints. The water management that the lime mortar provided, its ability to wick moisture out of the wall slowly, is gone. Moisture now accumulates behind the harder mortar. The timber frame, which was designed to work with a breathing wall, now sits in a wetter environment. The decay begins. Or consider the roof. You replace the clay tile with asphalt shingles. The shingles are lighter. The timber frame was overbuilt for the tile, so structurally it can carry the shingles. But now the roof surface heats to 150 degrees Fahrenheit on a summer day and sheds that heat into the attic space. The timber frame, which was designed to work within a certain temperature range, now experiences greater thermal stress. The asphalt shingles fail at year 17. The roof is opened for replacement. The timber frame, which was never meant to be exposed to weather, is exposed. The cycle of repair becomes more frequent and more expensive with each generation. The Old Order did not think about this as a system in the way an engineer would. They thought about it the way a farmer thinks about soil, as something that works when it is not disrupted, and fails when you start substituting components without understanding what each one was doing. What I have watched across 8 decades is that the houses, which are still standing in the best condition, are the ones where no one ever decided to update just one part. They are the houses where the original choices were respected, and repairs were made with the same materials as the original construction. That is a harder discipline than it sounds. It requires knowing what you have and why it works. I am not going to tell you to build a limestone farmhouse. Most of you cannot, and most of the places you live would not permit it under current building codes even if you wanted to. But I am going to tell you what I have watched the most thoughtful builders in this area take from the Old Order tradition and apply within the constraints of modern construction. Lime-based products are available again. After decades of near disappearance from the American market, hydraulic lime mortars and lime plasters are being produced and sold to builders who understand what they are for. If you are repointing an old stone or brick building, lime mortar is not a historical curiosity. It is the correct material, and experienced masons and historic preservationists have been saying so consistently for 30 years. The market has slowly responded. Clay tile roofing is available. It is more expensive than asphalt shingles at the point of installation, significantly more. But when you calculate the cost across a 100-year horizon, including replacement cycles, the math inverts completely. Builders who are constructing homes they intend to pass to their children are beginning to run those numbers and making different choices. Timber framing has never fully disappeared. There is a community of timber framers in this country who have kept the mortise and tenon tradition alive, who still use hand tools alongside their modern equipment, and who can build a frame that will carry load for 2 centuries. They are not cheap, they are not fast, and the structures they build are categorically different from what comes off a production framing crew. Wrought iron hardware is harder to source. True wrought iron, not mild steel finished to look like wrought iron. But blacksmiths who work in traditional iron are still practicing. The craft did not disappear. It contracted. And there are families in this country, Amish and otherwise, who still know where to find them. What I have watched across my life is that the knowledge does not die as long as someone is practicing it. The Old Order preserved these materials not by writing them down, but by continuing to use them generation after generation in buildings that still stand as the proof. The house on the edge of Lancaster County that I mentioned at the beginning of this video, the one built in 1803, the one where the fifth generation is living now, that house is the argument, not the theory of it. The house itself, still standing, still sound, still warm in winter and cool in summer, is the argument. 200 years is a long time, but it starts with the first wall. If you have made it this far, you are not a casual viewer. You are someone who wants to understand how things actually work, not just the surface of it, but the reasoning underneath. That is what this channel is built for. Subscribe if you have not already, because this kind of depth is what we bring every week. The next time we sit down together, it will be worth your time. Now you know why that house is still standing, and it was never luck. Thanks for watching. The end screen has more in the same world. Pick whichever one calls to you. Thanks for being here. Pick whichever video on the end screen calls to you.